Okay, welcome back, guys. Good afternoon. How's it going? Hope y'all are doing well. Just 3 minutes, pretty much, and then we'll get into the meeting today. But I hope you had a good weekend, and nice to be back. Hi, Brandon. Good to see you. Moises, welcome back. Angelina. Thanks, everyone. Alan, Nicholas. Nice. Just a couple minutes before I get things rolling. Hey, River. AJ. Good to see you. Hey, Derek. Daniel. Good to see you too. Hey, David. Got a good group already. Good to see everyone. Welcome back, Catherine. Hey, Sarah, Kirsten, Carson, welcome. Good to see everybody. Anna Lee, Spencer, appreciate you guys for being here. Kevin, welcome. And hey, Sylvia. And hey, Alicia, good to see you too. All right, everyone, it's 2:30, so let's just slowly get things going. Welcome back again, and as usual, hope you had a great weekend. Anytime you feel free, you can go ahead and just leave a little comment in the chat, just to kind of keep a record of your attendance. And yeah, so we continue to follow the calendar of the syllabus. We have just a couple of leftover notes that I wanted to talk to you guys about from the Descartes material that we were studying as we closed the meeting last time. And then once we finish with him, we will move into a new topic today. And so we'll start spending some moment talking about time and the theoretical analysis of time and space that we hear from Einstein, and how that's different from the older Newtonian conception of time and space. So we're going to start with time, but we have to finish up Descartes first. Also, just to let you guys know, I just in the previous few minutes before class, I finally sent around the link to the YouTube video that I was going to share with you about the Gettier problem. So whenever you have a chance, go back to that link and try to watch it. You know, it'll just help to reinforce and to deepen your understanding of the Gettier examples and how they showcase the problem with the classical account of knowledge. So, you know, just use that video for your own study purposes whenever you get around to it. You'll see it posted on Titanium as an announcement. So I just sent that today. Not anything urgent, but whenever you want, go ahead and check it out so that you're clear about Gettier. Okay, so let's just try to wrap up this material from René Descartes. A little bit more on him. Okay, so as I told you guys, René Descartes is a famous French philosopher of the early modern era. He lived from 1596 until 1650. And he wrote a book in 1641 called The Meditations, or full title, Meditations on First Philosophy. And what was the goal that he had writing this book? He said that we have to find out, well, does anybody have an answer to that? Let's see if I could touch base with you just for a brief moment. So does anyone think they could say just a summary statement, what did Descartes have as a goal when he wrote this book? What was the point of writing it? He was on a search for something. He was trying to figure something out, but what was he trying to discover or, figure out? What was the goal behind Mr. Descartes' book, The Meditations? Can anyone say that in a brief way, possibly? Just throw it over to you and see if you could give me something on that, and then I'll, add to it from there. So what was the whole point of writing the Meditations? Okay, Alan. He said human knowledge should be based on things that are absolutely certain and cannot be doubted. Correct. Very good. That's right. So Descartes said, I'm the one who's going to figure out what is certain. I need to know what is certain because we, in the century he wrote this, human beings are developing all kinds of new knowledge that was never known before. We're learning all kinds of things about science, about anatomy, about biology, about astronomy, physics, mathematics, geometry. So, even art, human knowledge is rapidly advancing during this time period. It's kind of like liberated from the oppressive structure of the medieval period where the church kind of ruled over all forms of secular and scientific knowledge. So anyway, he says, while knowledge is growing by leaps and bounds, let's make sure not to go off on the wrong foot and ensure that it's found on something absolutely certain. So he conceives of the expanding body of human knowledge as something that needs a base, a solid, secure base, such that we would never have any doubt about the things that are right there at that fundamental base. So it's a quest for certainty, this book. And he says in order to determine what is certain, we should utilize a method that he calls the method of doubt. And not to worry, Summer, I'm glad to see you here. Same to you, Jasmine, and everyone else that's joining us. Now we have another question as I'm reviewing the material from Descartes. We say that he was looking for certainty. Very good, yes, correct. What was the way that he said we would discover certainty? So basically he says use the method of doubt. But what is that? What does the method of doubt say to do or to assume? The method of doubt, someone will tell me. The method of doubt says that a person, to discover certainty, should assume what? On the basis of what? Who can give me the statement of the method of doubt? What's up with the method of doubt? It's always good after a weekend, when your mind's not on philosophy or whatever, to come back and have some of these notes presented again. So that gives us a sense of continuity, and we can remind ourselves of what we did last time. So the method of doubt, that's my question for anybody here. Who thinks they could tell me what is the method of doubt? It's something I think it's easy enough to say. It's pretty specific. But what does it say to do? Okay, very good, Alicia. So assume to be false anything that could possibly be doubted, even if it's possible to doubt it. We're not talking about highly doubtful, moderate doubt. We're talking about even if it's just even theoretically doubtful. If it's possible that it could be false, then the method of doubt says to assume until further notice that it actually is false. And continue to do the same until you find something in the belief system that cannot be doubted, that couldn't be false. And then if you get to that, you will have achieved the goal of the book, which is to find out what's certain. So using the method of doubt, once again, assuming, even if it's just for the sake of argument or whatever, but assume for the sake of argument that if something could be false, then it actually is. Well, what's one of the big things that he says right off, that we can say all of these things are capable of being doubted. He says all the beliefs that come from a certain source, at least in theory, they could be false. What are these major source of beliefs that he says we can call into doubt? All of them. All the beliefs that are based on, what was it called? So in other words, according to the method of doubt, all beliefs that come from blank can be doubted. Who can tell me how to fill in that blank? All the beliefs that are based on, that are derived from what? Good, Tina. All beliefs based on sense perception. So everything that you sense with your five senses, he says that could all be doubted. How though? How could I doubt right now what I'm seeing or hearing or tasting, touching? Smelling. How can I doubt that, that I'm holding a marker? I mean, it really looks like I'm holding a marker. To me, I feel like I am. But he says maybe you're not, because what could be going on that my vision would be just totally off and not correct here? How could it be that everything I'm perceiving is just false? If what? What's the possible case that makes him say that our senses cannot be 100% granted total trust? Because we have this possible scenario of what? That's right, Tina, dreaming. You say also, Jack, hallucinations. True, but he talks about dreams. Of course, hallucination would be another possible case where you think you see something, but it's not there. But he's going even farther than that, because when you're hallucinating, I mean, if you ever have, you're still going to be seeing some things in the environment that are real. But he raises this even more broad question that, you know, could everything that you are perceiving, the whole lot of it, could that all be false? Perhaps if you were dreaming. So imagine that you're dreaming right now, then this lecture is just fake. And even maybe your status as a student in college is fake. Maybe the body that you think you have is just something that you seem to appear to see, but in reality, it's not like that. So, you know, take a science fiction plot like The Matrix or Inception or something, the whole big plot twist. It was all a dream. This was all a dream is the kind of scenario we're just considering for the sake of discussion. So anyway, because dreams cannot be absolutely distinguished from real experiences, he says maybe everything you're experiencing with your five senses is just a big dream. So therefore, we're going to go ahead and assume that it is all false. So everything you perceive, let's just say it's all a dream and none of it's real, none of it's true. So that's where he kind of starts to wonder, is anything certain? The next question he asks is, well, maybe could stuff about mathematics and geometry be more certain than the things that I perceive with the five senses? Because you could argue that even if I'm asleep right now and this is a dream that we're having, or that I'm having, or that you're having, you could still say maybe that 2 + 2 = 4, or that there are 3 sides on every triangle. So those things might not depend on the status of being awake or asleep. They just depend on the concept of math or the concept of shape. So isn't that absolutely dead certain? And there, Descartes says, first of all, well, I don't know. I mean, God has awesome power. And God, if he wanted to, I guess, could manipulate your beliefs even about the most certain things that you see in math, like doing 2 + 2 and getting 4. Since God exists and he's all powerful, he could trip you out when you're trying to do even basic math, and maybe that's why it's not true. But then he says, okay, never mind though, God wouldn't do it, even though he could, because he's too benevolent. He's too good to do that. That would run contrary to his omnibenevolence. So he substitutes the example, perhaps not God, but in a different being that's below God but above us in terms of power and control, could be the one that manipulates your beliefs even about those questions. So maybe an evil demon, he suggests, could be the source of error, deceiving you about all the things. So after that, he closes the first meditation, the first chapter of the book. And that's kind of where I think we left off. He says, is there anything that I'm going to be able to hold on to? I'm using the method of doubt to try and discover what is certain, but it's starting to look like there's nothing there that is certain. But actually, not so fast. He finally says there is this one thing, though, that even the method of doubt cannot touch. And this is something that is dead certain. So who knows what that one was? The one thing that can't be doubted. The one thing that it doesn't even make sense to doubt, because saying you doubt it contradicts the thing that you say you're doubting. So what's this one thing that cannot be doubted? The method of doubt can't touch this. This is immune to doubt. One thing you know for sure is that what? Who could tell me that one item of certainty that survives this, hardcore method of doubt? One thing is certain. What is the one thing? Even method of doubt doesn't eliminate this certainty. The certainty that what? Or no, we've not spoken enough about it, so we can't say? Well, if we haven't said, then just guess. What do you guess would be the one and only thing that cannot be doubted by you? And this thing, to say you doubt it, is a contradiction. So can you guess, or whatever, what the one thing that's not doubted is? Okay, good, Derek. You say that we exist. And Alan, you say the mind. I want to bring these two things together, and you're along the right lines. You're getting to the right idea here. So, Derek, the way you put it is that we exist. You use the plural pronoun, we, which means more than one. Close, almost there, but just slight change to the wording. Who do you know exists, according to the method of doubt, Derek? Who specifically? You say we, but it's not exactly we. It's just which one? Someone you know exists. Who? Hint, there's only one. So who is it? Yeah, that you exist. You know that you exist, correct. Now, why is that not even possible to doubt? Because it's a contradiction in terms. Say this statement, I doubt that I exist. I mean, that does not make sense, because when you're formulating the thought, maybe I don't exist, then you're thinking that thought. So just the existence of your thoughts establishes that you, the thinker, do exist. So like we said before, what if everything around you is a dream and all of your five senses are just deceiving you? Well, even if this is a dream, there's a dreamer, you, having the dream. So at a minimum, even if everything reported to you by your senses is part of this big simulation world matrix thing that you're in, nonetheless, there's something that's experiencing this matrix, something that's experiencing this dream or simulation state. And so you know you exist, if nothing else. How come? Because you are thinking. Is that clear enough? You know you exist because you're thinking. So even if the particulars of the things you perceive are just dreams and illusions, the fact that you're a mind, even contemplating any of this stuff, is certain because there you are thinking. Okay, so we found something then, that the method of doubt cannot undermine or cause you to doubt. And this is the basis of a very famous quote of Descartes. So maybe some people who've never studied philosophy have even heard this quote. I know that it's kind of become something that pop culture has referenced, because even the musician Billie Eilish has had a song which has a title that's very similar to this quote of Descartes. So does anyone know of this quote? I'll try to hint at it so that I don't give it away, so someone can write it in the chat. But it's like, something, therefore something else. Do you think you've heard this quote of Descartes? Does the Billie Eilish reference help you catch it? Maybe, maybe not, I don't know. But she has a song title that is the second half of this quote. I think, therefore I am. Exactly, Alicia, yes. Well, let's get to your question in a moment, Jack. It's a very interesting question, but I wanted to highlight this quote. I think, therefore I am. That's correct. That is a quote that has escaped out of the world of the academy into many people's, I don't know, vocabulary. Some of us have heard this quote. So I think, therefore I am. Famous quote of Descartes, and that summarizes the point we were talking about. What it means, the quote, is that I'm thinking, right? So like you, for example, are thinking thoughts, and therefore, meaning conclusion, you exist. So since you're thinking, you know you exist. It would not be possible to say, hey, I'm thinking that I don't exist, because the thinker then would be denying the existence while they're thinking thoughts, but that doesn't make sense. So obviously, for you to have thoughts, you have to exist. And so on the very basis that you're thinking anything, whether it's a dream state, something real or otherwise, there's an existing being that's having these thoughts. I think the Billie Eilish song is just called Therefore I Am. But anyway, the full quote in English is, I think, therefore I am. In fact, originally published in Latin, this book, The Meditations. So the original Latin version of the quote is this: cogito ergo sum. Cogito ergo sum is the Latin translation of I think, therefore I am. And just so you know a little bit about the words themselves, if you've ever heard reference to cognitive behavior, like behavior of the brain, cognition, cogito is the Latin root of that. So cogito, consciousness. Ergo means therefore. And sum means reality, or to exist. So what this says is consciousness implies that you exist. So thought, therefore existence. Or if you like, in English, I think, therefore I am. So at last, there's something then that can't be doubted. The existence of the thinker, namely you. And let me read a little bit from the Descartes, and you can hear his way of putting it. So as the second meditation starts, the second chapter, he says, so serious are the doubts into which I have been thrown as a result of yesterday's meditation that I can neither put them out of my mind nor see any way of resolving them. It feels as if I have fallen unexpectedly into a deep whirlpool which tumbles me around so that I can neither stand on the bottom nor swim up to the top. Nevertheless, I will make an effort and once more attempt the same path which I started on yesterday. Anything which admits of the slightest doubt I will set aside, just as if I had found it to be completely false, and I will continue in this way until I recognize something certain, Or, if nothing else, at least until I recognize for certain that there is no certainty. So he says then, I will suppose then that everything I see is an illusion. I will believe that my memory tells me lies and that none of those things that it reports ever happened. I have no senses, body, shape, extension, movement. These are all illusions. So what remains true? He says then, trying to get to the key quote on the right column of 354. He says, But I have convinced myself that there is absolutely nothing in the world, no sky, earth, mind, body. Does it now follow that I too do not exist? And now we get the key. No. If I convince myself of something, then I certainly did exist. If there is a deceiver of supreme power and cunning who is deliberately and constantly deceiving me, in that case, too, I still undoubtedly exist. If he's deceiving me, and let him deceive me as much as he likes, he will never bring it about that I am nothing, as long as I think that I am something. So after considering everything very thoroughly, I must conclude finally that this proposition, I exist, is necessarily true whenever it is put forward by me or conceived in my mind. Okay, so something survives the method of doubt, and it's the knowledge of your own existence. But let's go a little further with the knowledge that he says we can still hold on to despite the method of doubt. When it comes to knowing you exist, question, do you know that you have a body? According to the method of doubt, anyway. I mean, I know that you believe you have a body, obviously, but like according to this method of doubt, if we're going to limit ourselves to what it allows us to say is certain, can you say that you have a body is certain? Do you know for a fact, I mean, you know you exist, but do you know that you have a physical body? Question, just let me know what you think. Based on the method of doubt, do you know that you have a physical body? It's a yes or no, so you just got to take a side. But think about it. According to the method of doubt, do you know that you have a body? Okay, David, you say no. Good, correct. Why? Why is it that your body is still something that's subject to doubt? You should be able to tell me, since you have the right answer. Why, according to the method of doubt, is the knowledge of the body not certain? And look here, my hands are right in front of me. But we're being told that you don't know for a fact that they're real. Why not? Yeah, well, your senses. I mean, it's a very brief way you've put it, David, but I think I understand your meaning. You perceive the body by means of the senses. So, like, when I look at my body, I see it with the eyes. But we've been told that the eyes, ears, nose, etc. are all subject to this dreaming illusion type of doubt. So it's possible, I guess, that in the real situation where you actually are, you're just a mind that thinks that you have this body, or you're just like a vapor cloud that thinks that you have this kind of physical form, but it's all part of the big illusion that the mind is just entertaining as it goes through these dreams or whatever they are, simulations. So the existence of the body is not totally certain. So what is this thing that you are that you know to exist? At minimum, all you know that you are is a mind that is thinking, an immaterial, disembodied like soul, because the existence of all things physical, including the body itself, are within the realm of doubt according to the method of doubt. So the only thing you're certain of, correct, Ismail, according to the method of doubt at this stage, is of your own existence. And based on your question, I have another little follow-up, which I think is helpful. So thanks for your question. Let me ask you this. According to the method of doubt, do you know that I exist? Do you know that I exist? We've said that you know that you exist. Okay, good. Do you know that Professor Vulich exists? Is that certain or no? Yeah, it's not certain. My existence relative to you is not certain. Why not? Why don't you know that I exist? Just trying to walk you through the reasoning. It's the senses again, correct, Ismail, because my existence, how do you know of it? I mean, you think you know of it because you can see me through the screen or hear my voice. But it's possible that I, as well as everything else around you, is just one of these things that you're dreaming in your mind or in your imagination while you're going through the simulation world. So who is the one and only person that you know to exist? Not even physically, but at least as a mind. Just you yourself. So, I mean, in a way then, the method of doubt really limits you to this one item of certainty. You know that you exist, and that's it. You don't even know if you have a body or if anything physical exists, but you know at a minimum that you're one thing that thinks and has experiences. Because with respect to all other people, third persons, others relative to you, you don't have the ability to perceive their thoughts from the inside, right? Relative to you, everyone else is an external object. So you only have first personal access to the content of your own thoughts and mind. Therefore, others, it's fair game to suppose that those are just illusion people. Like when you have dreams, okay, and you're hanging out with your friends in your dreams, those aren't your friends. Those are figments of your imagination, and you didn't actually spend time with your real friends during the dream. So if this is a dream, then it's possible that me and everyone else is just part of that dream, and you're the only one that's actually real. Now, okay, let's step back from the brink a little bit, and I'll try and indicate to you where this will ultimately head later, because that's where we pretty much are going to wrap up our discussion of Descartes for now. But I told you that there's more to his book than the first 2 chapters, and later on in a couple weeks we will read the 6th chapter, the last one. And ultimately, by the time he finishes his big book, he takes a big path, a big loop back to common sense, but he does so slowly and deliberately. So this is just a preview of something that we're going to talk about later in a lot more depth. But basically, here's how his argument continues from there. He says, okay, well, you know you exist, but everything else, all bets are off, at least according to the method of doubt. But one thing you can hold on to is the knowledge that you exist, if nothing else, as a mind. So with your own existence as a mind, one thing that's clear is that you have ideas. And within the mind, the ideas that you have, one of them, he says, stands alone because it's very special. It's the idea of God. And he says that idea of God that is in your mind is unique because it's the only idea he thinks that we have of something infinite. Everything else is the idea of something limited in time and space. But the idea of God is the idea of something infinite and unlimited. So he says that one idea can only come from something that's also infinite, because he doesn't believe that any finite thing could transmit to you the idea of an infinite being like God. So that is his kind of little ontological argument. He says, in your mind, there's the idea of God, and there has to really be a God because the idea is too great, basically. After that, he continues by saying, now that I've proven, he thinks he's proven that God exists, it follows that God is perfect and good, so he wouldn't trick you. And with God's guarantee, you can be sure that when you have clear and distinct perceptions that they're accurate to the facts. So that's how he gets back to the point that we can trust our senses and that the world does exist. Because if it did not, then God would be playing tricks on you, which he would never do because he is just too good and nice. So therefore, go ahead and trust your senses. There are other minds, there are other people, there are external objects, and your senses are accurately reporting on them. But he takes this, little detour into the claim that God exists, because he says, if I didn't make that part of the argument, we would never get back to the conclusion that you can trust your senses. You'd just always be in a state of doubt. So he thinks the guarantee of accurate perception that is provided by this benevolent God is the only way that you can ever really trust that the things that you think are happening are really happening. Now, I don't know if I agree with every step of his argument, which continues after the second meditation, but it's a powerful piece of reasoning. It's captivated many minds, and so obviously it's something that I'm responsible for teaching you guys, and it's a classic of philosophy. So that's where we're going to end the Descartes discussion for today. But like I say, we'll pick it up again in a few weeks, and we'll complete that whole remaining part of the argument. But for now, anyway, here's what we've learned. Descartes was on a quest for certainty. He said, unless we find something certain, we're going to build up all this knowledge, but later on we might have to just throw it all out because we realize that something at the very foundations was false. So let's find some certain, secure foundations that are totally true, that no one can doubt. Use the method of doubt to get to the certainty. Method of doubt says to assume to be false whatever can be doubted, even if it's highly unlikely to be doubted. If it can be, assume it's false. So with the method of doubt, all the things we perceive with our senses could be doubted through the possibility of dreams. Even math and logic could be doubted, he says, because of the possibility of an external deceiver, not God, but perhaps an evil demon. So what remains? The one thing that remains is that you exist because you're a thinking mind, even if you're dreaming all of the stuff. And that's where the second meditation pretty much leaves it. But as I hinted and explained, we will get to the remaining parts later, and at the end, through the steps I kind of explained, he will say that we can actually repose certainty and confidence in our perception. but only on the basis of his long, complicated argument, not just, just assume it's real. Okay, so there we go. We finished up the last part of the Descartes essay, and I wanted that to start today's meeting. So from there, next, we move to the next topic of the semester. Okay, so let's take stock of where we've been, and then we'll chart our course forward and press on from here. So far in the class, we started with the philosophy of religion, arguments bearing on the existence of God, trying to prove that God exists, objections to those arguments, and everything in between. Then we studied ethics for a little while. We learned about utilitarian ethical philosophy, Kantian ethics, how they differ, what they're all about, how they might address questions like whether we have obligations to the global poor, trolley problem. And after the midterm, we studied epistemology, which is now just what we've wrapped up. That's the theory of knowledge, the study of human knowledge. What is knowledge? That takes us all the way back to the ancient Greek world and Plato and Socrates, who argued in favor of justified true belief as the definition. Fast forwarding 2,000 years later to the more current day work of Gettier, the American philosopher who said in 1963 that justified true belief is not an accurate definition of knowledge, because we can have counterexamples where a person has those conditions but still does not know. Think Gettier's Smith and Jones job hunt or the other examples mentioned there. And then now we've finished with Descartes, who said that we have to set down a foundation underneath human knowledge of certainty. And utilizing the method of doubt, he believed we could establish certainty, which ultimately gets him into the position that we know that at least one thing, that you exist as a mind. Now we continue through the semester with a new topic. And the topic for us now is metaphysics. Metaphysics is a word in philosophy. It's another big branch of philosophy, just like ethics, philosophy of religion, epistemology. Another one is metaphysics. And what metaphysics is all about is like a sort of deep investigation of the nature of reality and what exists. So okay, so metaphysics originally was a word coined by the ancient Greek philosopher Aristotle. He wrote a book called Metaphysics. It's a famous classic of philosophy, ancient philosophy. And in his usage, it just meant to go beyond what we know through physics. But in the generation sense, it's kind of taken on a slightly different meaning, and it's this meaning. It's just a deep, focused, kind of penetrating investigation into the fundamental nature of reality. What is there in this universe and in reality, and what's the nature of the things that exist? Now, given that very broad description, metaphysics can take a lot of different topics as its subject matter. So hold on one second. Like, for example, sometimes within metaphysics, people are interested in the question of human free will. Do we have free will, or are we just determined to act as we do? And, we think that we have freedom and the ability to just make choices to do whatever we want. Some people might argue, though, that we're actually determined to act in the way that we do by the physical forces of the universe that we're embedded within. Another question that metaphysicians could ask would be, how does an object endure across time? As you know, you look at a photograph of yourself from 10 years ago when you're a child, perhaps, and it's still you. I mean, that person is you in the photo, but it's a much smaller person, and if some of you know, like every cell in your body has completely been recycled over a 7 or 8 year span. So the person that you are today doesn't even have one cell in common with that photo of you from 10 years ago, but it's the same person. And so how is it that an object maintains identity across time as it's constantly shedding parts and adding new ones and stuff? So another question could be persistence and endurance of identity across time. Other times we could ask about the nature of objects and properties. But the topic of metaphysical inquiry that I've chosen for us, which is in our book for this part of the class, is to explore the metaphysics of time. Okay, so what I'm going to have us investigate and review in the book and in our lectures is the concept of time. What is time? what is the best current day understanding of time that we get from Albert Einstein and the theory of relativity? And how is that conception of time scientifically and philosophically different than the older paradigm that we had before him, which was Newtonian conception of space and time? So we will have several meetings that discuss time, starting with the work of Albert Einstein, and we'll take a quick crash course in the theory of relativity and what that shows. Afterwards, we will go on to talk about some of the more philosophical puzzles that emerge once we reconceive of time along Einstein's lines. And then we'll even have a little bit of brief discussion about some of the fun and metaphysically puzzling concepts about time that are advanced, like time travel, whether it's theoretically possible or not. Okay, so metaphysics of time is the current subject, and it's going to occupy us for a couple weeks. Okay, so the first author then on this topic, like I was saying, to get our bearings and get us oriented to the new topic, we have Albert Einstein. Albert Einstein, world famous, widely known household name, right? This is the genius physicist, scientist who really revolutionized the modern day understanding of time and space. He is a man that lived from 1879 until 1955. And, you know, he's arguably the greatest physicist ever to have lived. So impressive are his theoretical achievements in science and physics. As a young person, just in his early 20s, like 23, 24 years old, working at the patent office in Germany where he was employed after graduating college, he just worked on physics papers in his spare time, you know, kept track with the latest cutting-edge results in theoretical physics and science. And from that hobby horse type of pursuit on the side of his patent clerk work, he developed these Nobel Prize-winning papers in physics that were published in 1906 called On the Electrodynamics of Moving Bodies. And in that document, we basically learn of what is called special and general theory of relativity. Now, the special and the general theory of relativity are quite intimidating for an average layperson who's not deeply steeped in like advanced mathematics and physics. So what Einstein wanted to do about 10 years later, after the initial publication of these groundbreaking papers, would be to write a book that could somehow explain the ideas to a more general audience, because he wanted his ideas to be well understood by the common person. So in 1916, 10 years after the initial publication of his Nobel Prize-winning papers in physics, in 1916 he published a book which he simply titled Relativity. And in that book, what he tries to do is to break down his heady ideas to a more general audience of readership so that more people that were not necessarily specialists in math or science could understand and comprehend these ideas. It's still a little technical, still a little difficult to bring it down to earth, but you know, Einstein does his best, and this is therefore a little bit more accessible and readable. Now, the paper that we are reading in our textbook, it is a section that's removed from this book of 1916. So if you went to the original source text, you'd see that it's from Einstein's Relativity book, 1916. In our textbook anyway, they just take one small section out of there and they retitle it. So for the purposes of our textbook essay, here's what the title of the paper is. It's called Time and the Relativity of Simultaneity. Okay, time and the relativity of simultaneity. So that's what is titled in our book from 1916. Again, Albert Einstein, the author. So for the rest of today's meeting, with the time we have, we'll try to cover as much of this as we can. Okay, so now Einstein, again, he's famous for revolutionizing the modern understanding of time and space. Prior to Einstein, the dominant view was Newton and Newtonian physics. And the essential main difference between Newtonian conception of physics and the relativistic conception of Einstein is that under Newton and Newton's view, We thought that time and space were completely independent of each other, that they were two separate factors that had no ability to influence each other. So on Newton's idea, no matter how fast or slow an object is moving through space in terms of its velocity through space, Newton believed that that could not have any possible impact on the rate of time passing, that time would always pass at a constant and fixed rate, and that no matter whether an object was moving fast, slow, relative to other objects, that that could never alter or modify the quantity of time that passes or the rate at which time passes. So Newton thought time and space are independent. When objects move through space, they have no effect on how fast or slow time is going. But what Einstein was able to show is that this is not correct, that time and space are not independent and separate, but rather that they're woven together into one unified structure called space-time. So there's actually an integration between time and space. And according to the space-time conception of Einstein, how fast or slow an object is moving through space actually does have an effect on the rate at which time passes for that object relative to other objects that don't have the same state of motion. So once you come to understand this relativistic conception of time and space, you'll come to learn that it has very puzzling, deep, bizarre, and even trippy implications for us and our position within the universe. So it has like very, very deep and kind of awe-inspiring implications and results that I'll try to reveal to you in the best way I can. So let's go on and start with the breakdown of his paper, Time and the Relativity of Simultaneity, Einstein, 1916. Okay, so with that information, I can clear the board and just create some new notes. I want you to suppose this, and this is what Einstein says. To get us started, he gives us a thought experiment, a hypothetical scenario to envision, okay? So scientist and philosopher Einstein says, suppose there's a railway track. So this line that I'm drawing, let's just suppose that what that is a track of a railroad. So a train would travel along this track. I want you to suppose that two lightning strikes occur on this railway track. So here's lightning strike, the first one, and here's the other one. Let's mark them off at the 2 points where they occur along the railway with the letters A and B. A and B. So like the left side, this is lightning strike A. On the right side, lightning strike B. Just to give them a label so we can refer to the two. Next, let us suppose a deceptively simple assumption. I want you guys to assume something that probably, you wouldn't even bat an eye or think twice if I said this, but suppose that the two lightning strikes occur simultaneously, okay? So that's it, just assume that they happen simultaneously. And now Einstein has a question for you that's kind of a tricky one. He says, okay, so we're saying that these two lightning strikes happen simultaneously, yeah? Tell me, what does that mean? Definition, simultaneous, what is it? What does it mean for two events to be simultaneous? And see if you can give an answer, but here's the thing. Einstein says that when you think about it for a moment, after you reflect, you're going to realize this is not so easy to answer as it seems. It's a deceptively simple question, but it's hard to give an answer. What does it mean for two events to be simultaneous? The reason that this is hard to say is because any attempt to define it, like what you're saying right now, David, basically runs up against circularity, because whatever definition you give is going to basically amount to the same thing. Like you're going to say same time as. For two events to be simultaneous, that means they happen at the same time. But happening at the same time is elliptical for the concept of simultaneous. So we're asking, in a way, a deeper question. What does it mean for two events to happen at the same time? Can you define simultaneous without saying anything that is just a variation of at the same time? Is there a more contentful, fulsome description of what it is for two things to happen at the same time that doesn't just say happening at the same time? See, if we just say simultaneous means at the same time, that's like saying simultaneous means simultaneous, which is circular, and it doesn't add any kind of explanatory value to the explanation. So I know that it's not like 100% of us have jumped up on this. I appreciate your contribution, David. That's very good because we need to have the feedback from students. But if any of you other guys wanted to try and attempt the definition, I'm sure you're going to have a similar difficulty, because spin your wheels for a minute, same time. Would you say they happen at once? They don't happen at different times? One happens and at the same time the other one happens. These are all just more or less wordy ways of saying the two events were simultaneous. And what Einstein says is that, okay, well, let me read. Here's what he says. He says, lightning has struck the rails on a railway embankment at two places A and B distant from each other. I make the additional assertion that these two lightning flashes occur simultaneously. If I ask you whether there's meaning to that statement, you will say yes. But if I now ask you to explain to me the meaning of the statement more precisely, you will find after some consideration that the answer to this question is not so easy as it appears at first sight. So I see, Carson, you suggest they happen parallel. Jasmine, you say occurring together. Yes, these are all noble attempts, and I appreciate it, but it's like even the genius, you're in good company if you find it hard to give a non-circular description, because the genius Einstein that we should all, I think, respect with some degree of intellectual appreciation, he himself is saying this is not so easy to define as it seems at first. Now, the next thing he says is this. He says some people feeling stumped that they couldn't give a definition of simultaneous that doesn't just repeat the concept of same time as. He says some people might like just shrug their shoulders and come back and say this to Einstein. Come on, man, do we really need to define it in such detail? Why is that important? I mean, if I say, you know, I dropped my phone and simultaneously I got a phone call, everyone will know what I mean. No one will stop and say like, hold on, what? What does that mean though, simultaneous? Like people will understand in everyday conversational contexts. So no one's going to have difficulty utilizing the word in real life. And so he imagines maybe a person replying to his question in the following way. I don't know if I can explain it, but who cares? Don't we kind of already understand it anyway? And so this detailed definition you want me to give is just superfluous and besides the point. But Einstein says, no, I can't let you have that kind of just shoulder shrugging, come on, simultaneous means whatever, do we really need to answer it? He says, no, because as a scientist, you have to have a concept like this defined precisely. Otherwise, it may not have any real meaning. So here's what he says. After some time, perhaps, the following answer would occur to you. And he places this in quotes because he's speaking in the voice of his imagined, you know, interlocutor. So someone might say, the meaning of the statement is clear by itself, and it needs no further explanation. Now, of course, it would require some consideration if I was commissioned to determine by observation whether in the actual case the two events took place simultaneously or not. And Einstein now reports back to that. He says, I cannot be satisfied with this answer for the following reason. Suppose that as a result of ingenious considerations, an able meteorologist was to discover that the lightning must always strike the places A and B simultaneously. Then we would be faced with the task of testing whether or not this theoretical result conforms to the reality. We encounter the same difficulty with all physical statements in which the conception simultaneous plays a part. And now here's the key quote. He says, the concept does not exist for a physicist until he has the possibility of discovering whether or not it is fulfilled in an actual case. We thus require a definition of simultaneity such that this definition supplies us with the method by means of which we can decide by experiment whether or not both the lightning strikes occur simultaneously. And he continues, as long as this requirement is not satisfied, I allow myself to be deceived as a physicist, and of course, even if I'm not a physicist, when I imagine that I'm able to attach a meaning to the statement of simultaneity. And then he says, I will ask the reader not to proceed any farther until you're fully convinced on this point. So let me explain a bit what he says. What he's saying here is, if you're a physicist, you have to have a very detailed working definition of a physical concept like simultaneous. You can't just kind of wave your hands and be like, oh, you know, it means something. We kind of all get it. Can we just move on? He says, no, for a physicist anyway, a scientist, you have to have a definition of a concept that is so clear that we could actually perform a physical experiment to test the proposition of whether the two events are simultaneous. So he says, in a way, what I'm asking you for then is the following. Can you tell me how to conduct a experiment or test which could give us the result of whether the two events are simultaneous or not? And he says, if you don't even know how to test for the question, then you might be operating with an undefined concept that actually has no literal meaning. So then, he says, I insist that we have a precise definition, so much so that we could actually test the question. So here's our new question. What is the test that we could perform to determine whether or not the two events were simultaneous? And he says, until you agree with me that we need to be able to, you know, establish the method of test, that don't read on any further. So now I think we're convinced we need to find out how to test whether they're simultaneous. So here, how do we test that? Einstein says, okay, I got you. I'll tell you how to test for this question, whether they're simultaneous. So current question, what is the test that we could use to determine whether the two events are simultaneous or not? Okay, he proposes this. He says, let us measure the distance between the 2 points A and B, okay? And since that's a significant specific interval of space, that can be a line segment AB. So consider point A to be the initial point, point B to be the terminal point, and that's a line segment described as the line segment AB. Now, for every line, there's a midpoint, right? I don't know if you've studied your geometry, but even if you haven't, I'm sure this is intuitive and clear enough. If you have a line, there's one point that's the midpoint. What that means by definition is it's the point that bisects the line. So when the midpoint exists, there's an equal distance between the midpoint and the first part of the line and the midpoint and the second part. So let's designate that midpoint here and label it with the letter M, standing for midpoint. So this midpoint space is exactly halfway between A and B. So from A to M is equally distant from B to M. Yes, David, it will have to do with point of reference, but allow me to explain a little further, and these pieces will all come together slowly for you. Let's now place an observer here at the midpoint M. So this is like a stick figure just to denote that we have a person who's interposed between A and B. All right? Now, that means, again, that he's equally far away from lightning strike A and the space where it happens, and lightning strike B and the space where it happens. Next, here's an important point. We have to make sure that our observer is positioned far back enough to see both of the regions of space in one field of vision, right? So like when you're looking out into space, there's a visual frame, I guess you could say, which is the field of vision that's shown to your eyes as you're looking at whatever the scene is. So right now, in your visual frame, you have this screen, I'm assuming, and whatever in your peripheral, the background around you in your room and stuff, right? Now, why do you think it's important that we position our observers far back enough so that he can see A and B in one visual field, instead of, for example, being so close to A that he would have to like turn his head to see the second point? Can you understand? This is key. Just want to make sure we're all on the same page. Why is it that Mr. Observer has to be able to observe the 2 points A, B without averting his eyes? Or let me ask it differently while you're thinking of how to answer that one. If he was so close that he couldn't see them both in one visual field, would he be in position to judge whether they're simultaneous or not? If he was too close to see them both, could he even observe whether they're simultaneous? I hope that makes sense to you. What's the answer? Why does he have to be far back enough to see them both in one visual field? Or what would be the case if he was too close to see them both in one visual field? Could he still conduct his observation? I just want to make sure this is clear to you. So David, your answer no, I suppose, is in response to the second way I phrased the question, which was, in case he's too close to one to see the two in one, in the same field of vision, then he could not possibly observe and determine whether they were simultaneous, because say that he's like looking at A real close up and he sees, boom, lightning flashes. And then he quickly turns his gaze to the other area B and he sees lightning flashing. Well, under those conditions, he could not establish whether they were simultaneous or not, because it takes time, obviously, to change the direction of your focus from left to right. So it could have been that while he saw A strike, in the split second that it took him to turn his head towards B, B started to emerge, and they happened out of sequence with each other. So clearly he has to be able to see them both in one and the same visual frame. If he is not able to do that because he is too close, then Einstein simply says, supply him with mirrors that are inclined at 90-degree angles, and then the mirrors can be positioned in such a way that he can see both of them in one field of vision. So he's either far back enough or supplied by means of mirrors so that he can see the two regions of space in one field of vision. Okay, and that's what he says here. He says, after thinking the matter over for some time, you offer the following suggestion with which to test simultaneity. By measuring along the rails, the line AB should be measured up, and an observer placed at the midpoint M of the distance AB. The observer will be supplied with an arrangement For example, two mirrors inclined at 90-degree angles, which allow him to visually observe both places A and B at the same time. Now, simply, if the observer in that visual vantage point perceives the two flashes in one visual perception happening at once, then relative to him they would be simultaneous. But actually we have to add just one further stipulation to make this test functional. Okay, we have to make this assumption, that the speed of light is constant and fixed from every direction to every other direction in space. Good teacher. So basically we have to assume that the velocity of light never changes, that it's always constant and remains at a fixed value. In other words, we have to assume that the speed that light moves from A to M is the same velocity that the light is moving from B to M. And to make this more clear, I want to take a sidebar for a moment and ask you guys, how is it that vision works, okay? How is it that vision works on a physical, scientific level? So like you're looking at this video right now. How is it possible for you to see it? Like what is the mechanism by which the eye sees things in space? Tell me how it works, if you have any basic idea. It's not magic, right? It's not like magic eyes that just see stuff. How do they work? Can you tell me that? Even if it's light. Okay, very good, David. It's light. And I'll give you more details. So when you look at something, how can you see it? Well, light rays reflect off the surface of that object, and then they bounce towards your eye and your retina. Your eye collects the visual information contained in the light that reflects off of that surface, and then the brain processes it, and you see the image of whatever it is. Okay, so without light, there's no ability to see. Light is the conveyor of visual information off of the reflected surface of the object seen, and then communicated to the eye because the light travels from the object and its surface towards your eye. Okay, to make this even clearer, I try to explain things as many different ways as I can to make it sink in. So here's another way to look at it. When you close your eyes, why can't you see anything? What is happening physically that makes it such that when you close your eyes, it's just a blackened field of vision. You don't see anything around. It's obvious in a way, but I want us to state the obvious so that we make sure that we're always in touch with things that we can clearly understand. So with closed eyes, how come vision doesn't happen? What's being prevented? Well, you say it's dark, right, Jasmine? And to be specific, Alicia, you say there's no light. So the shades of the skin that covers the eye when you close your lids, it blocks incoming light from being able to strike the retina. And so with the eyes closed, light can't get inside the eyelids, so you don't see the objects around. Okay, so light is the conveyor of visual information. Now, that means that when Mr. Observer at the midpoint sees A and sees B, he can only see them by means of the light rays that travel from the initial point A towards M and from the initial point B towards M. So we must stipulate that the speed of light is constant from A to M, and it's the same velocity as the speed of light from B to M. Now, if the speed of light is constant, then we have these factors held fixed. The distance from A to M is the same as the distance from B to M, because M is the midpoint. By definition, the distance from A and B to M is equal. Furthermore, we are now supposing that the speed of light is equal. So not only is A to M the same length as B to M, but the velocity of light traveling from A to M is the same velocity as the velocity of light traveling from B to M. So if they've traveled the same speed, the same distance, and they've reached an endpoint at the same time, then we can logically deduce through math that they have departed from their respective origin points at the same time. But it is only on the assumption that the speed of light is constant that this condition of observation will allow us to assume simultaneity. Let me explain that. So suppose that the speed of light was not constant and it varies from place to place. For example, suppose that the speed of light of A to M is twice the velocity of the speed of light from B to M. Under those conditions, even if they reach the midpoint at the same time, since they are traveling at different velocities, they would not have departed from their respective origin points at the same time. Let me give you a metaphor or an analogy to make that clearer. I want you to pretend, just for the sake of illustration for just a moment, that A going to M and B going to M are not rays of light given off by lightning, but rather runners in a foot race. Okay, so I want you to suppose, for the sake of discussion, that A is a person and B is a person, and they're lined up at the starting line of a race. And so since it's a race, there's a set distance, and it's equal for all the race competitors. So let's say M is the finish line of the race, and up here, they're at the starting line. Now, suppose that A is twice as fast of a runner as B. Twice as fast as B. Okay? A is twice as fast as B. So whatever speed B runs, A runs a factor of 2 times faster than that. So 2x, where x is the speed of B. Now suppose that the twice as fast runner and the twice as slow runner reach the finish line at the exact same time. Okay? If the two runners reach the finish line of an equally long race at the same moment, then who left first? One guy's twice as fast, one guy's twice as slow, but they meet at the finish line simultaneously. If that was the case, then who departed first from the start line? Can you compute that one? So when you have a twice as fast guy and a half as slow guy that meet at the end, who left first under those assumptions? Supposing that they both move at constant velocity once they do start. Who left first if the fast and slow guy meet at the finish line at the same time? Yes, the slower one left first, because, hopefully this makes sense, it's like the tortoise and the hare type scenario. This guy's twice as slow, right? He's twice as fast. So starting gun goes off, and he's going. But when he gets to about half, this guy's like, okay, let me catch up. And he starts, and because he's twice as fast, they meet at the finish line. So we cannot assume, therefore, that light is like these runners that are moving at variable speeds. Otherwise, the common receipt of the two light signals from their respective origin points at the same moment would not allow us to deduce that they had departed from their origin points at the same time. So when we stipulate that the speed of light is constant and fixed, it enables this observer's perspective to generate the desired result. So relative to him, the two events are simultaneous if, when posed equidistant from the two sources of light, they reach him at the same moment, on the assumption that the speed of light is constant. So here I'll read it. He says, if the observer perceives the two flashes of lightning at the same time from the midpoint position, then they are simultaneous relative to him. I'm pleased with the suggestion, but for all that, I cannot regard the matter as quite settled, because I feel constrained to raise this point. The definition would be right if only I know that the light by means of which the observer at M perceives the lightning flashes travels along the length A to M with the same velocity as along the length B to M. And then he says, this is a stipulation which I can make of my own free will to arrive at the definition of simultaneity. So now we've said what the test is for means of verifying simultaneity. Place an observer in a midpoint position between two events, and if he receives the light signals from the two equally distant events at the same moment, then relative to him, they must have been departed from the two origin points at the same time. In other words, are simultaneous. Using this kind of definition of simultaneity, the receipt of incoming light signals from two separate events by the perceiver in the same visual perception, this allows us to define the simultaneity of any two events. Take, for example, the way that we use a clock to coordinate our movements in time and space. Suppose that we were back to face-to-face classes, and this class met, I don't know, at Cal State Fullerton, Humanities Room 101, Monday and Wednesday, 2:30 to 3:45. So in that case, if I say to you, make sure that you're there at the appointed time on Monday at 2:30, you could convert that into the discussion of simultaneity in the following way. You could say, well, here are two events that have to become simultaneous. The observation of the pointer hand of the clock, or the digital face of the clock showing the indication 2:30, that should be observed by my eyes simultaneous with me sitting down in the seat at that point in space. So two events happening simultaneously is just the light rays from the two things being caught by the eyes at the same moment of a given observer. And what are clocks? Clocks are just reliable instruments that we can assign events to by making those events observable at the same time that the reliable pointer hand of the clock shows a time indication. Now that's already kind of trippy and weird, thinking about the concept of two events being simultaneous in relativistic terms in relation to when the two events arrive to the visual system of a standard perceiver. But it's about to get even much weirder than that, because what I'm going to show you next is how, according to the same analysis that we've heard now, the concept of simultaneity is not absolute, but rather it is relative. And that is the part that's really, really trippy, weird, and just mind-boggling. So let's try and cover that. I want you to next imagine a second observer on the scene, okay? So this guy's still here. He's still at midpoint M, standing still, and conducting his observation from that position. But now I want us to add a second observer to the scene, and this second observer is not standing still at M, but rather is on a moving train. Now this train is where the second observer is positioned, and they're moving in the direction of travel from A towards B with constant velocity v. So v here is just a value for whatever the velocity of the train is. This person is moving with the train with that constant velocity while the other guy here is standing still. Now, for any system that's in motion, we can describe a different frame of reference if there is an observer who shares that reference frame's state of motion. One frame of reference then, is the perspective of the motionless observer here at M. But a different frame of reference is the frame of reference experienced by the observer on the moving train, which has velocity v. So he regards all events in relation to the moving train and its state of velocity, and he regards all events relative to his motionless state at the midpoint. So when two different objects are moving with relation to each other at different speeds, variable speeds, they have these different frames of reference. If there was a person orbiting the Earth in a space shuttle, then while they're in the space shuttle, they appear to be kind of at a state of rest, but relative to us, we would say, oh, they're spinning so much faster than us. So two different reference frames, the terrestrial observer and the guy in the shuttle. Okay, anyway, so here we have this observer who's moving along with the moving train from left to right. I want you to now imagine the following thing, that as he continues on his path from left to right, he traverses the midpoint, which lies directly in between A and B. And so to designate the midpoint as it is seen from his frame of reference on the train, let's label it M prime instead of M. So M prime is just the midpoint as observed and seen from the point of view of the moving train observer. Now, suppose this, that as he continues along with velocity v, he intersects for that moment with the midpoint that this guy is also arranged at on this plane. And for that split second, they're like aligned. He is at M prime and he is at M. I want you to suppose that while that brief split second of alignment happens, it's like rolling, 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 pause the video. At that point, he's at M prime and this guy's at M. Now, because he has constant velocity v, he's not going to remain at the midpoint M prime if we were to hit unpause on this playthrough of a video. So I'm kind of asking you to imagine that this was like a recorded video of the train moving as the other guy does his observation. If we allow it to play until the point where we hit pause, and then he is at the midpoint, that is the moment in time when this guy is conducting his observation and sees the two lightning strikes happening as simultaneous from his viewpoint. But if we were to continue to allow the video to play, what would happen to the guy that's in the train? Will he stay at M prime or will he move? Okay, so it's like, press play. Train's rolling, pause. This guy's at M prime. Hit play again. Does he stay at M prime or does he move? The guy in the train, not the initial observer, but the second one that's got velocity v. What will happen to the second observer in case we allow the video to continue playing through as he surpasses and traverses the midpoint? Does he stay at the midpoint or does he continue on to the right? He does move and he continues to the right with velocity v of the train. So now, this is the trippy thing. With respect to the second observer who's in that train moving with v, velocity v, question, do you think he will see A and B happening simultaneously in the same way that the motionless observer saw A and B happening simultaneously? Will the second observer see them happening both at the same time or happening at different times out of sync? What do you think? Given his state of travel and the direction of travel and the velocity that he has, even though he's momentarily aligned along this plane with the guy at the midpoint, he continues his direction of travel towards the right, towards B, because he's in constant motion. So what of the two events do you think the second guy will see happening first? We will not see them happening simultaneously. So in the train observer's point of view, which of the two events will he see happening first? if he's doing his observation while he passes the midpoint at the same time the first guy does his observation. Okay, David and Jasmine, correct. He does see them out of sequence, and they are not happening simultaneously relative to him. But if you had to guess, which of the two do you think he would see first in the order of events? The second observer. So they're non-simultaneous to him. Which is first? Correct, David. It's B and then A. You got it. Now, why is that the right answer? Why is it that B occurs first to his visual perception, and then a subsequent moment later, it is A? Very good, everyone. You've got it. B is seen first, afterwards A. What's the physical explanation according to what has been presented here? Why is it that he sees this one happen initially and not at the same time? What is the difference then between him and the guy that's at M? Because the guy at M sees them happening as though simultaneously. So, well, David, you say B is in front of him. Kind of, but I don't want anyone to get confused. So here's one thing I don't want anyone to think. Don't suppose that because this one's behind him, he can't see it or something. That's not true. So it's not like just a simple fact of he can only look in one direction, and this one's behind him, so he's going to have to turn around, and then he won't know. That's not it. So don't think that, because once again, we give him the means by which to look at both points in space in one field of vision. So the one behind him, he can simply have a mirror that's standing right here while he looks at the other one in front, and he could still check and see the two events. So it's not as though pointed in this direction means you don't see anything behind you. It's not that. But there is something to do with his state of velocity and the way that light is perceived by a visual system. So why do you think it is? Let me see, Jasmine, your suggestion. Because he stopped at the midpoint when it happened and his view is B. Well, Jasmine, also not correct. He didn't stop. I'm talking about we playing a video in which we hit pause. But when you hit pause on a video, the people that were filmed originally didn't pause in actual reality. You understand? So, David, you say this. The light of A is in the same direction of the velocity. The light propagates through all directions into space. So the only issue is this, guys. It is because he's closer to B and further from A. He's got velocity v, so he's moving. He's a moving target. His visual system does not stay interposed at the midpoint. So even though for that brief moment that this guy's observing things while he's standing still at M, even though for that brief moment he's in the same position at M prime, he's passing through this whole thing continuously with constant velocity. There's no actual pausing. I was trying to describe that for you as though we were watching a video that replays the original events. But since he passes through the midpoint, he's going to be closer to B and further from A while this person conducts his observations. So since the speed of light is the same from B as it is from A, they are not going to be able to reach his visual system at the same time because there's asymmetrical lengths. There's a shorter length between himself and B because he's closing that gap on it. And there's a longer length between himself and A because he's expanding the gap between himself and A because he's running away from this light ray and he's running towards the light ray that's emitted from B. So can you guys understand that the asymmetric distances, A has to go further than M to reach him. B has to go a shorter distance than the midpoint in order to reach him because the direction of his travel and the velocity that he does have. So if these were two runners running the same speed, they run at the same speed to a stationary object and meet at the midpoint here. But if you have this moving target that starts off by running away from the midpoint towards the right, then this guy just doesn't have very far to run to reach him. Even though this guy's got the same velocity, he has farther distance to travel to meet up with that eye. Okay? So here Einstein said it. He says, are two events which are simultaneous with reference to the railway embankment also simultaneous relative to the train? We will show directly that the answer is negative, no. When we say that the lightning strikes A and B are simultaneous with respect to the embankment, we mean this. The rays of light emitted at the places A and B, where the lightning occurs, meet each other at the midpoint M of the length AB of the embankment. But the events A and B also correspond to positions A and B on the train. Let M prime be the midpoint of the distance A to B on the traveling train. Just when the flashes of lightning occur, this point M prime coincides with the point M. But the observer moves towards the right in the diagram with the velocity v of the train. If an observer sitting in position M prime in the train did not possess velocity, then he would remain permanently at the midpoint, and the light rays emitted by the flashes of lightning A and B would reach him simultaneously. But in reality, he is hastening towards the beam of light coming from B, while he is riding on ahead of the beam of light coming from A. Therefore, the observer will see the beam of light emitted from B earlier than he will see that emitted from A. Observers who take the railway train as their reference body will therefore come to the conclusion that the lightning flash B takes place earlier than the lightning flash A. And we thus arrive at the important, stunning result. Events which are simultaneous with reference to the embankment are not simultaneous with respect to the train, and vice versa. In fact, every reference body has its own particular time, and unless we are told the reference body to which the statement of time refers, there is no meaning in a statement of the time of an event. Okay, so has this hopefully sank in a little bit? The reason is in a way simple. There's two different distances that light has to travel to reach the guy that's in motion. Because as he traverses the midpoint while he does his observation, the two light signals will only have to travel from A to M or from B to M. But since he's in constant motion, not at rest, his state of velocity ensures that A will have to go farther to catch him than B will. And since they move at the same exact speed, 300,000 kilometers per second, 186,000 miles per second, that's the speed of light, then moving at the same speed but having to travel asymmetric lengths, they're going to reach their target at different times. If two objects are both moving 20 miles per hour, but one has to go 10 miles and the other has to go 20 miles, then they're not going to reach their destinations at the same time. The one that has a lesser distance to travel at that velocity will get there first. So now here's the really kind of weird, trippy thing. I'm going to ask you a trick question. So try and think about the fact that it's a trick question and give me a tricky answer. The two lightning strikes, A and B, point blank, are they simultaneous or not? And it is a trick question, but think about it and see if you can type out an answer. Given what we've learned here from Einstein, the two lightning strikes, are they simultaneous events or are they not? It's a trick question because the answer is that it's, what do you think? What do you think is the answer? Simple question, but a tough answer. Are they simultaneous or not? We've had two different answers in a way, so think about that as you type out what you're going to say. But this is the end, so we got to get this point out there so we can close the meeting. Yes, depending on where the observer is standing and whether or not they are in motion. Very good, Alicia. So the right answer is basically that it is, what's that word? It's relative. There's no objective fact. So some of you might have been sitting there thinking, what does he mean? I mean, it is simultaneous, right? The second guy, he just doesn't see it the right way or something, but it is like factually simultaneous, right? No, that's totally wrong. It's relative. It's relative all the way down. Neither one is like the correct observer. So you should not be sitting there thinking, but he's getting it right because he's standing still. The other guy's in motion, so he sees like an illusion or some kind of distortion of the real order of events. No, no, no. Because no observer has a privileged position on which to observe the events in space and time. You think you're at rest, but you're not. At any given time, you're moving, and the reason that you think you're at rest is just because you don't have the same state of motion that some other object in the universe has. At all times, you're on the surface of the Earth, and the planet is zooming around the sun and orbiting at an extremely high velocity. You don't notice that because we're all on the same planet together, moving as one. It's kind of like being in a car that's driving fast. While you're inside the car, you know, you look like you're just sitting still. But to people that are outside of it, they see you whizzing past. So it's not as if this person standing at M is like the motionless observer that all events should be defined in reference to him. He has just as much plausible claim to be the correct so-called observer as the other person does. And so it's deeply relativistic. There is therefore no objective answer to what order the events happen in. And that is very, very, very weird because it starts to tear away the whole notion that there's a linear time sequence. And the broader implication of this is that all the events of space-time are equally real, inclusive of the ones that you think of as having been in the future and not having any definite nature yet. Keep in mind that relative to this observer, when B happens, A is still located in his future. It hasn't happened yet because he'll see it afterwards. Relative to this person, they happen at the same time. And if we added a third observer who's going from right to left in the opposite direction of travel towards A and away from B, and if he intersects with midpoint M double prime, right as he's going to the left with velocity V, then he's going to see A happen and then B afterwards for the same reason, but just in the opposite direction. And each of these three observers, relative to themselves, sees the events in the order they do happen for that person. So it's like A and B are simultaneous, and A and B happens before A, and A happens before B, and all three of these are equally valid descriptions of reality depending on the person's frame of reference and their state of velocity relative to the other observers. So it just gets much, much weirder because now we start to learn that we cannot actually order any of the events in time and space objectively. And that makes you wonder how it is that your own life is sequenced, because you look at tomorrow as happening after today, yesterday is happening before today. But on this account, any two events could be assigned as simultaneous or happening in reverse order, depending on the observer's position in space and their state of velocity relative to the observed events and other observers. So there's more to say about it, but this is just our opening kind of gambit into the Einstein. So appreciate you guys for sticking with me and learning some cool, heady material. We're going to continue on the same theme Wednesday, so just continue reading through the syllabus. And I'm going to make sure to assign the second paper prompts later in this week too. So we'll talk about those paper prompts a little bit on Wednesday, I hope. Okay, guys, so let me let you guys go. Sorry to keep you for an extra minute. Let me see in the chat that we're all good for the moment. Okay, thank you, Alicia, Annalie, and everybody else. It's great to be with you guys and have another nice lecture. So have a good one and take care for the next few days. If you need anything through email, please let me know and I'll be in touch. But until then, have a good one and I'll see you soon. Okay, bye.